Good day everyone, my name is Emer Valles and we are the Group 3 of IS-204. And today we will be performing an experiment regarding the exogenic processes. Exogenic processes driven by natural forces such as wind play a significant role in shaping the Earth's surface through erosion, transport, and deposition of materials. Among these processes, aeolian activities are particularly influential in arid regions, where wind acts as a powerful agent of desertification and landform alteration. This laboratory experiment focuses solely on the aeolian-oriented process, simulating the effects of wind on different soil types, which include sand, loam, and rocky soil, under varying angles of elevation. By observing and measuring changes in soil thickness after exposure to wind, the students will explore the mechanics of wind erosion and its role in shaping landscapes, therefore providing insights into the dynamics of desertification and other wind-driven phenomena.
The materials we used for this experiment includes an aluminum tray with holes, 500 grams loam soil, rocky soil, and sand, a wind source, a protractor, a ruler, a marker, gloves, and the lab coat.
Now, here's what you need to do to conduct this experiment. We should always start with safety first, so to avoid having stains on your clothes and having messy hands, don't forget to wear your lab coats and gloves. Make sure to do this experiment in a place with lots of room because it might get messy. To do this experiment, first, you need to fill the aluminum tray up with sand, loam soil, and rocky soil. Next, make sure to measure the thickness of each sample using a ruler while making sure that each sample comes to an equal flat height of 1 inch and is aligned with each hole from the aluminum tray. Next, elevate the tray from 0 degrees to 40, then 60, and then lastly, 80 degrees while using a protractor as a guide for the angles. Next, blow some air on the top of each sample using a wind source, which is in our case, a fan, for 5 seconds, then repeat the process while observing the angle of elevation mentioned a while ago. Don't forget to observe and record the changes.
In our experiment about how exogenic processes affect desert erosion, we examined how landslides, wind, flowing water, and glaciers influence different types of soil such as sand soil, loam soil, and rock soil. We situated a tray containing these soil samples at various angles and observed the changes in thickness for the mass wasting portion. Because sand soil is so loose, we discovered that it is most susceptible to erosion. We replicated wind conditions with a handheld fan to investigate wind erosion. This demonstrated that loam soil and rocky soil stayed together considerably better than sand particles, which flew away quickly. We poured water over the soil samples for the water portion of the experiment and measured the amount of water that flowed off. Compared to sand, which drained away more moisture, loam soil retained moisture better. To demonstrate how melting ice can move soil, we lastly allowed melting ice cubes to slip down the tilted tray. Our experiment demonstrated how wind, water, and glaciers sculpt desert regions, emphasizing significance of these natural processes in desert growth and erosion.
This experiment demonstrated how exogenic processes, wind, gravity, water, and ice, shape Earth's surface. Sand was most affected by wind and water due to its low cohesion, highlighting its vulnerability to erosion, especially in arid regions prone to desertification. Steeper slopes increased soil displacement and mass wasting and water erosion, while glacial activity altered terrain through melting and sliding ice. Overall, these processes work together to transform landscapes, emphasizing their importance in understanding and managing environmental changes.